Peridot is one of the very few gemstones on Earth that forms deep inside the mantle, far below the crust where every other common mineral grows. It reaches the surface only when violent volcanoes drag it up, which is why it turns up in a few specific places and almost nowhere else. In this country, it shows up in old volcanic rock and in the creeks and washes that drain it, sitting there as small green grains. A clean, deep green stone can be worth real money, and even the rough material has a price that surprises most people who find it. This video covers what peridot is and how it forms, along with exactly how it is found in nature and what a rough piece is worth. It also happens to be one of the oldest things you could ever hold, since some of these crystals are older than the planet under your feet. If any of this helps you out in the field, subscribe to the channel and leave a like, since that is what keeps these videos coming. So the first thing you need to know is that peridot is simply the gem-quality form of a very common mineral called olivine. Olivine is one of the main building blocks of the mantle, the thick layer of hot rock that sits far beneath the thin crust we live on. In raw terms, it is one of the most common minerals on the entire planet, since a huge share of the whole mantle is built from it. The catch is that almost all of it is locked miles underground where nobody can reach it, and the rest is dull and grainy at the surface. Gem peridot is the rare exception, a pocket of olivine that happened to grow clear and evenly colored before it was carried up. To grow into a gem, it needs to sit quietly deep down for a long time, forming clear and even before any eruption disturbs it. Then it needs a fast eruption to lift it out, so gem peridot depends on slow growth and a sudden rise happening in the very same spot. That green never changes and it never fades, and it comes from iron built directly into the structure of the crystal as it grew. The intensity of the green depends on how much iron sits inside, so a richer color usually means a little more iron in the crystal. Pure magnesium olivine is nearly colorless, and it is the iron creeping in that pushes the crystal toward that familiar green. Too much iron turns it brown and cloudy though, so the best green sits in a narrow window of just enough iron and no more. The color runs from a fresh lime green to a deep olive, and the finest stones show a rich grassy green with a faint golden warmth. Peridot comes only in that single green, so there are no blue or red or yellow versions of the stone for you to go chasing after. It is a fairly hard stone, sitting between 6.5 and 7 on the mineral scale, so it will scratch ordinary window glass with ease. It is not as tough as quartz though, so it chips and cracks fairly easily, which starts to matter once you are handling the raw pieces. Here is the part that makes peridot unusual. Since it does not form in the crust at all, where nearly every other gem people hunt begins. It crystallizes tens of miles down in the mantle at temperatures and pressures that no process near the surface could ever come close to. For you to ever hold a piece, something has to reach down into that layer and haul it all the way up to the surface in one push. That something is a particular kind of volcano, one that erupts fast and deep and tears loose chunks of the mantle on its way upward. The eruptions that manage this are not the slow oozing kind, since a slow rise would give the crystals time to dissolve and break down. They are fast and driven by gas, punching up from great depth in a matter of hours, which is the only way a mantle chunk survives intact. The very same olivine has turned up on the Moon and on Mars, and even in the dust of passing comets, which shows how common it is. Those torn loose chunks are the key to this whole hunt, and geologists call them xenoliths, which simply means foreign stones. A xenolith is a lump of deep rock that the rising magma ripped free and carried upward without melting it down completely along the way. When that magma cooled at the surface, it hardened into dark basalt, and the mantle chunks froze inside the black rock like raisins in bread. So a peridot crystal begins its life deeper than any mine could ever go, and it ends up locked inside a piece of plain-looking volcanic rock. There is one other way peridot reaches us, and it is genuinely from outer space, inside a rare kind of meteorite called a palisite. A palisite is a slice of a shattered world, a mix of metal and green olivine, and cut thin, it shows gem peridot glowing between the iron. Those meteorites are pieces of the zone where a destroyed planet had its metal core meet its rocky mantle, which is why they mix the two. Most crystals that come up this way stay small, and only a lucky fraction ever reach the clean, cuttable size that a jeweler wants. That kind is far too rare to hunt on purpose, and it sells to a different market, so the peridot you can realistically find comes from basalt. So now you know it lives inside basalt, and the next question is what that actually looks like on the ground once you go out searching. The first thing to look for is dark volcanic rock, since without basalt, there is no host for the crystals and no reason to search at all. Basalt is a dark gray to black rock, often full of small round holes left behind by gas bubbles as the lava cooled and hardened. Those gas holes are called vesicles, and a rock riddled with them is a clear sign that you are looking at genuine volcanic rock. A young peridot-bearing flow often looks like a cap of dark rubble sitting on top of the paler and older ground all around it. Inside the good flows, you find rounded lumps of a coarse green rock, and those lumps are the mantle xenoliths that you are hunting for. The bombs often have a dark rind of basalt wrapped around a green core, so a green center inside a black skin is exactly what you want. Not every basalt flow carries them, since only the eruptions that reach deep enough to grab mantle rock will hold any peridot at all. Prospectors call them olivine bombs, since the eruption fired them out like projectiles and dropped them across the surrounding ground. Crack one open, and the inside is a mass of granular green crystal, sometimes dull and cloudy, and sometimes clear enough to be cut. In the best nodules, the green olivine makes up most of the rock, with the darker minerals scattered through it as a small minority. Most of that green is too fractured or too cloudy for jewelry, and the real gem material hides in the clearest patches inside the lump. Fresh basalt is hard and stubborn, so cracking bombs out of it by hand is slow, heavy work, even with a good hammer and plenty of patience. Wear eye protection whenever you hammer that rock, since basalt throws sharp chips and a green crystal is no use with an injured eye. Do not crush the green crystals themselves, since one whole clean grain is worth far more than any pinch of powder could ever be. Weathered ground is far friendlier, since the rock has already rotted over ages and released its crystals into the loose soil on top. So the easiest surface hunting is on an old flow that is sat exposed for a long time, where green grains lie loose in the dirt. After a rain, those grains really stand out, since the water washes the dust away and the wet green catches the light against dark soil. A hand lens earns its place here, since much of the gap between a cloudy grain and a gem grain is only visible up close. The grains behave like any heavy, durable mineral once running water gets hold of them, so they gather in the washes and creeks below a flow. That means you can pan and screen creek gravel for peridot the same way that people work a creek for gold or for garnet grains. Work the same traps you would work for gold, meaning the inside of the bends and the pockets behind boulders where heavy material drops. Scoop down to where the heavier gravel sits and screen out the fine sand, since the peridot rides with the black sand at the bottom. The black pyroxene in that same gravel has a darker glassy shine and no real clarity, which helps you sort it from the clear green grains. In a few volcanic places, the grains are so abundant that whole beaches turn pale green, made of almost nothing but tiny olivine sand. The green sand beaches of Hawaii are the famous example, though collecting or removing that sand is restricted and often flatly illegal. Now for the other minerals that share this exact setting, since peridot never rides up out of the mantle completely on its own. The green rock the crystals sit in is called peridotite, and it is essentially solid mantle, one of the deepest rocks you will ever touch. Mixed through that peridotite, you find black pyroxene, a dark, glassy mineral that grew right alongside the olivine in the same deep rock. You also find spinel, showing up as small, dark red to black grains scattered through the green, and here it mostly acts as a marker. Its presence confirms that you are looking at true mantle rock, so a few dark spinel grains are a good sign on any green nodule. The most striking companion is chrome diopside, a pyroxene with an intense emerald green that is even brighter than the peridot beside it. Chrome diopside is itself a cut gemstone, so finding its vivid green grains tells you plainly that you are standing on genuine mantle material. So the ideal find is a chunk of black basalt holding a green peridotite lump flecked with black pyroxene and dark spinel and bright diopside. That single rock is a small sample of the deep earth, and it tells you at a glance whether a given volcanic flow is worth your time. You can scout likely ground from a map, since a named volcanic field or a marked lava flow points you straight toward basalt. A patch of dark rubble sitting oddly on pale desert is often an old flow, and that is exactly the kind of spot worth a closer walk. Before we get into where this rock actually sits in this country, I want to point you to something that goes deeper than a video can. I run a members area on this channel where each month I take a single gem or mineral and break it all the way down to the field tests. If you want that level of detail, tap the join button on your screen and come work through it with the rest of the community. Now for where this actually sits in the United States, since a handful of volcanic fields produce nearly all of the peridot found here. By far the largest source is Peridot Mesa on the San Carlos Apache Reservation in Arizona, which supplies most of the peridot on the market. That single basalt flow is packed with mantle xenoliths, and the loose green grains lie so thick there that they can be gathered by hand. There is a hard limit you have to respect though, since that ground is tribal land, and only San Carlos Apache members may collect there. Outsiders cannot simply drive up and dig, and treating that boundary with respect matters far more than any stone you could carry off. The next major spot is Kilbourne Hole, a wide volcanic crater in southern New Mexico that was blasted open when magma hit groundwater. Its rim is littered with dark basalt bombs, and many of them hold green olivine, some of it clear enough to cut into small gems. Access there has shifted over the years, so check the current land status and any permit rules before you plan a trip out to it. Beyond this country, most of the world's finest large peridot now comes out of the mountains of Pakistan, which sets the top of the market. That foreign material competes with anything you dig here, so a common Arizona grain will never fetch a Pakistani mountain price. One more locality worth naming is the remote volcanic country of far southeastern Arizona, where scattered flows carry olivine as well. The material there runs smaller and cloudier, so it rewards patience and a hand lens far more than it rewards a casual afternoon. Hawaii produces enormous amounts of olivine, and its beaches and flows are covered in green grains almost everywhere you care to look. Most of that Hawaiian material is small and only translucent though, and removing sand or rock from many of those sites is against the law. Wherever you look, the underlying rule stays the same, since peridot only shows up where deep volcanic rock hauled mantle material up. Once you have a green stone in hand, a few simple checks will tell you whether it is really peridot or just green glass or common rock. Start with the color, since real peridot holds that oily olive to lime green tone evenly, with no blue in it and no dull gray cast. Hold it up to the light and it should look glassy and transparent, glowing with a slightly greasy shine on any freshly broken surface. Test the hardness next, since peridot scratches glass with ease while softer green stones and plain bottle glass will not touch it. Look closely through a clear grain and you often see doubled edges inside, where the back facets appear as two lines instead of one. That doubling is strong in peridot, and it makes a reliable sign, since ordinary green glass never splits the image inside that way. The grains also tend to be rounded and a little cracked from their violent trip without the sharp crystal faces you see on many gems. Peridot has a glassy to slightly oily luster, and a fresh break curves like the inside of a shell instead of splitting flat. Under the lens, many stones show tiny disc-shaped inclusions that cutters call lily pads, which are a helpful mark of a natural peridot. The streak it leaves is white, and a stone stays that bright olive green no matter which way you turn it under the light. A quick word on fakes, since Peridot is cheap enough that few people bother faking it, which honestly works in your favor as a hunter. Green glass is the main thing that fools people, and it gives itself away by its softness and by the missing doubled image inside. Peridot is almost never treated or heated either, so the green sitting in your hand is the true and natural color of the stone. Color grades the price more than anything, since a pure grassy green with no brown pulls far ahead of a pale or muddy stone. Clarity comes next, since a clean, transparent stone is worth much more than one clouded with cracks and inclusions inside. Now, for what it is worth, since that is the question everyone asks the moment they realize the green stone in their hand might be real. Small cloudy grains and plain industrial olivine are close to worthless, and huge tonnages of it get mined for steel making and other uses. Clean rough that a cutter can actually use is where the value starts, and even small clear pieces carry a few dollars for each carat. Larger clean rough with a deep even green climbs quickly, and fine pieces can bring well over $100 for a single carat. Once it is cut, ordinary peridot sells around $50 to $80 a carat, and top color in large sizes reaches several hundred. The value climbs steeply with size, since large clean crystals are uncommon, and a big deep green stone is far rarer than many small ones. So a single clean rough crystal the size of a pea can genuinely be worth more than a whole bucket of the cloudy grains around it. A cutter loses much of the weight in shaping a stone, so a rough piece has to be a good deal larger than the finished gem you picture. Be honest with yourself about the odds, since most of what you gather will be small, cloudy grains fit for a collection and little else. Keep your finds sorted by size and clarity, since a buyer or a cutter always wants the best pieces kept apart from the common grains. If you do find a promising flow, take only what you need and fill any holes, since these sites are limited and easily wrecked by careless digging. There is one more gem worth knowing before you go, since it comes out of the same volcanic basalt country that Peridot does. That gem is Sunstone, a feldspar that crystallized inside basalt lava flows, and the state of Oregon is famous the world over for it. The best-known Oregon sites sit out in the high desert of the southeastern part of the state, well away from the volcanic Peridot ground. You dig the sunstone straight out of weathered basalt and the soil around it, much the way you would work a weathered Peridot flow. Sunstone sits in that basalt for a different reason, since it grew inside the cooling lava itself as the flow slowly crystallized. Oregon sunstone ranges from pale yellow to deep red and green, and the finest stones carry a glittering shimmer of copper flecks inside. That trapped copper is what gives the best Oregon stones their flash and their strong red and green color that collectors chase. Several Oregon sunstone sites sit on public land where anyone can dig for a small fee or even for free, which the Peridot ground never allows. A fine red or green sunstone can bring several $100s a carat, so it is genuinely worth learning about right alongside the Peridot. Learning the two together makes sense, since the same eye that learns to read a volcanic flow will end up spotting both of them. Both stones reward someone who can read basalt and sort a heavy concentrate by eye, so the same field habits carry straight across. If you want to get confident at telling all of these stones apart, I put together an ebook that walks through it step by step. It covers the simple at-home tests for hardness and color and shine, along with the common lookalikes that fool most beginners. It is built so that someone with no background at all can pick up a strange stone and work out what it really is on their own. You can find that ebook linked in the description right below this video, and it is there whenever you feel ready to take this further. If now is not the time for that, there is no problem at all, since you can keep learning here for free by subscribing to the channel. Leave a like if this helped you out today, and then watch the next video that is already waiting for you there on your screen. In it, I go through another stone that most people walk straight past in the field without ever knowing what it was really worth. Thanks for liking and subscribing. Good luck, Gem Hunter!